Hello everyone. Today we want to learn how to remove brackets from algebraic expressions. This means we'll use multiplications to expand everything inside the brackets. This rule is called the distributive property. Now we want to solve some examples together. Let's look at the section E in here, which we write this expression a times this term inside the bracket, which is m minus n, when we want to expand this. The letter outside of the bracket, which is a in here, needs to be multiplied by this term inside the bracket. And since we have two terms inside the bracket, which one is m and the other one is minus n, we need to multiply this term outside of the bracket by each of these terms individually. So the first one would be a times n, which would be equal to am. And the other one would be a times minus n, which would be equal to negative an. And the final answer would be the summation of these two terms, which would be equal to am minus an. So we just combine these two answers together and we get the final answer, which would be the expression without the brackets. Now let's move to other problem. We have 7 times this term inside the bracket, x, y. As you see in here, the term inside the bracket, there is only one term inside the bracket, which is the x times y. If there was a plus or a negative sign in here, we would have actually had like 2 or at least 3 or 4 terms. But since there is only a multiplication between these two variables in here, this one would be considered as one term. So we can simply write this as 7 times x, y. And this would be our final answer. When there is only one term inside the brackets, just multiply directly. You don't need to expand it anymore. Now, let's solve another one. Let's say we want to solve m, which is 7 times x plus y. As you see in here, we have a plus sign in here, which means these two terms inside the brackets are being separated from each other. So we need to multiply 7 by each of these terms individually and just add the values together. So the multiplication of 7 and x could be 7 times x, which would be 7x. And the multiplication of 7 times y would be equal to 7y. And we just combine these two answers. It would be 7x plus 7y, and would be our final answer. Now, for the final example, let's solve r, which is 5 times p minus 3q. Now, we want to distribute the 5 to both terms in here, and we will multiply the 5 in both terms in here. So the first term is p in here, and the second term is what? Minus 3q. As I said before, when there is a plus or negative sign between two variables, that means you have to separate them. Like the question on E, M, and what's happening on R right now. There is a plus or negative signs in here, so we have to separate them. So the first one would be actually 5 times P, which would be equal to 5P. And the other one would be 5 times minus 3Q, which would be equal to minus 15Q. And the summation of those would be 5P minus 15Q. Now, on this question, we are now expanding the expressions that have two brackets. Each bracket has two terms, and we need to multiply every term in the first bracket by every term in the second bracket. So, in order to do so, we're going to start with A, which we have these expressions in here. 2 plus A times 3 plus B. So, what I said was, you need to multiply each of these terms by each of these terms in the bracket. So let's look at the first term in here, and we're going to multiply this 2 by this value, and we're going to multiply 2 by the other term as well in the bracket. We also need to multiply a by this term, the first term, the second bracket, and we need to multiply a by the second term on the second bracket as well. So it would get us, the multiplication of the first one would be 2 times 3 plus, we always combine the answers and we add them up. So it's like the combination is the same thing that we used to do in the first bracket as well on the previous questions. So we have the first multiplication, which is 2 times 3. The second multiplication would be 2 times b plus. Now we go to the second term on the first bracket, and we need to do the same process. The multiplication of the second term in the first bracket would be a times the first term on the second bracket plus now a times b. And we have 6 plus 2b plus 3a plus ab. Now let's solve another one. Let's solve d. We have x plus 5 times x minus 3. So we do the same thing again. We multiply each of the terms in the first bracket by each of the terms on the second bracket. So let's look at the first term first. X needs to be multiplied by x, and it needs to be multiplied by minus 3 as well. So we have two terms, which is x and minus 3, and we have two terms on the first bracket, which is x and plus 5. Don't forget the negative sign in here. Now let's look at the second term on the first bracket. We have 5. 5 needs to be multiplied by x as well, and it's also need to be multiplied by the minus or negative 3 in here. So let's rewrite the equations now. We have x times x plus we have x times minus 3 plus we have 5 times x plus we have 5 times minus 3. Now we're gonna write the equation and simplify it. So x times x would be equal to x to the power of 2, and x times minus 3 would be minus 3x. The third one would be 5 times x would be 5x. And the last term, which is a constant in here, would be 5 times minus 3, which would be equal to minus 15. And we take away 3x from 5x, which would be equal to 2x. So we have x to the power of 2 plus 2x minus 15. Now let's try more problems related to expanding expressions with brackets. We want to start with question number E in here. We have x plus 2 times x. If you look at this expression, it looks like there is only one bracket, which is actually in here. But actually, there is an imaginary bracket around the x as well. Why? Because x is just one term and we don't need to write brackets for a single term. So we can rewrite this as x plus 2 times x. Now we have two brackets. As you remember from the previous questions, in order to expand this, we mentioned that they should multiply each of the terms on each bracket by the other terms on the second bracket. So we have one term in here that needs to be multiplied by this. And we have the other term in here that needs to be multiplied by this. And then we need to combine them. So we have x times x plus 2 times x. And we will have x times x is equal to x squared. And we have 2x in here. Let's solve another one. D. We have x plus 11 times x minus 7. Now, the brackets are visible in here because we have two terms on each of these brackets, at least. So what we should do now, we should do the same process that we did. We multiply each of the terms on each bracket by to each of the terms on the second bracket. So we multiply x by x, and we multiply x by -7, and we do the same thing for 11. We multiply +11 by x, and we multiply 11 by -7. So we should note that we should consider minus or -7 in here as the second term, and we shouldn't forget the negative sign in here. So let's do the process again. We have x times x times x plus x times -7 plus 11 times x. We headed to the second term in here, which was 11. Now we are multiplying it by the terms on the second bracket. So 11 times x, and we have 11 times -7, which would be the last term. So we have plus 11 times -7. And we just simplify it. X times x would be x squared. X times -7 would be like -7x. 11 times x would be plus 11x. And 11 times -7 would be -77. And we can write this, we can take away 7x from 11x, which would be x squared plus 4x minus 77. Now let's solve the last one, and you can do the others at your convenience. So let's solve J. We have 3x plus 5 on the first bracket, and we have 2x minus 1 on the second one. So we do the same thing. What is the first term in here? 3x. We need to multiply it by each of these terms, which is 2x, and -1 is the second term. So the first term is 2x, and the second term is the -1, and you do the same thing for 5. 5 times 2x and 5 times -1. So 3x times 2x, then plus 3x times -1 plus, we have 5 times, now we headed to the second term, 5 times 2x, and we have on the last term plus 5 times -1. And we have this equation, 3x times 2x would be 6x squared, and we have 3x times -1 would be -3x, and we have 5 times 2x, which is 10x, and we have -5 at the last. And we can simplify this more, and we say it would be equal to 6x squared. Take away 3x from 10x would be 7x, and we have -5 at the end. Now let's look at another example. This time we want to expand the expressions within brackets using algebraic identity. As you know from the algebraic identity, IV, we have x plus a times x plus b would be equal to x squared plus a plus b times x plus a times b. We have this formula from the algebraic identity formula number 4. Now we want to use this in order to expand these brackets in here. So let's look at a in here. We have s plus 1, s plus 5 times s minus 3. First, we want to multiply these two parentheses in here and use this formula. So we have s plus 1 multiplied by s plus 5. As you see in here, this s these two s's in here act as an x in this formula. So we can write this as s squared plus the summation of these two, which would be a and b, which is 6 times s, plus the multiplication of these two, which would be 5 times 1, which would be equal to 5. So if we expand these expressions, we would actually be expression like this. Now, after we got the multiplication of these two brackets, we're going to just multiply this expression in here by the last bracket. So our final answer should be s2 plus 6s plus 5 multiplied by s minus 3. Now, what you should do the same process that we used to do on the earlier questions. We should multiply each of the terms on each bracket by each of the terms on the second bracket. So the first bracket, the first term would be this one, and it should be multiplied by each of these terms in here. The first term is s, and the second term is -3. We do the same thing for 6s in here. 6s should be multiplied by s, and it should also be multiplied by -3. And we do the same thing with 5 as well. So 5 should be multiplied by s, and it also should be multiplied by -3. So let's write the equations. S squared times s would be equal I'm not going to simplify it now, just write the equation. S squared times s. The second one would be plus s squared times -3. Let's move to the second term, which is 6s. 6s times s plus 6s times the second term, which is -3, plus we have the third set in here, which is 5 times the first term, which is s, plus 5 times the second term, which is -3. Now we're just gonna simplify the equations in here. So we're gonna write the first term would be s cubed, and this second term would be -3s squared. This one would be plus 6s times s would be 6s squared. The fourth term would be 6s times -3 would be -18s, plus we have 5s in here, and at the last we have -15. So we're gonna simplify it more. We're gonna take away the s squared terms together. We're gonna take away the s terms in here, and we're gonna leave -15 and s cubed as they are, because they can't be simplified more. So we're gonna rewrite s cubed in here. These two terms, these two s squared terms needs to be actually canceling out each other. So we're gonna take away 3s squared from 6s squared. It would be leaving with 3s squared, and these two terms in here we have 5s and -18s, which we actually take away 18 from 5 would be -13s, and we have -15 at the last. Okay, on this example we want to learn how to factorize algebraic expressions. To factorize means to write an expression as a multiplication, just like reversing expansions. We're going to look for the HCF between all terms, and we can actually do the factorizing process. So on this example, we're going to solve B and D, and the rest can be solved by you guys at your own convenience. To solve B, I'm just going to rewrite the question again, 3x minus y. So the first step in order to factorize this equation in here is to find the highest common factor between these two numbers, which are 3 and -9. The highest common factor, as you guys remember from the previous examples, is the highest number or the highest value that you can divide both these numbers by. So What is the highest number that you can divide 3 and 9 by it? It would be equal to 3. So HCF between 3 and minus 9 would be equal to 3. After we found the HCF, which is 3 in here, we can factor out 3 from this expression in here, and we write it outside of the bracket. And what you should write inside the bracket is that you should divide each of these terms by 3 and just write the answer in here. So what is 3x divided by 3? It would be equal to x. And what is minus 9y divided by 3 would be equal to minus 3y. So that would be your factorization in here. Now let's look at another example. D, which is 4x plus 32z plus 16y. As you see in here, we have 3 numbers, which is 16, 32, and 4. We do the same process again. We should find the highest common factor, which was the biggest number, that we can divide all of these 3 values by it. And after that, we can actually progress with the factorization. So the highest common factor between 4, 32, and 16 is 4 itself. And we are going to do the same thing. We're going to write 4 outside of the bracket in here. We factor out 4 from this expression. Then what you should do, you should divide each of these three terms in here that you see, each of these 3 terms, by the value of 4. So you divide all of these by the value of 4. So what is the division of the first term? It would be equal to x. What is 32z divided by 4? It would be equal to 8z. And what is 16y divided by 4 would be equal to 4y. Okay, now in this example, we want to learn how to factorize algebraic expressions that involve fractions. Although these may look more complicated than whole numbers expressions that we used to see, the process is exactly the same. We need to identify and extract the highest common factor from all the terms. For this purpose, we're going to solve b and d, and the rest can be solved by you guys at your own convenience. So for b, we have 2 over 3 pi r cubed plus 1 over 3 pi r squared h. So we basically have 2 terms in here. This is the first term and this is the second term. And we want to find the common factors in each of these terms. So the first term, as you see in here, has a 1 over 3 in itself, and the second term has a 1 over 3 in it as well. So this would be our numerical part, which is actually identical in both of these terms. So we have 1 over 3 in both of these terms in here. The reason for the first one is that the 2 over 3 is actually 2 times 1 over 3. So it is obvious that this value, this numerical part in here, consists of 1 over 3 as well. So this is the first common factor. We go ahead and find the next one and we multiply them. What is the second common factor in here? It is pi itself. As you see, both of these expressions seen here has the pi value in them. So this is the second one. What is the third factor that is common in both of them? We have r squared in both of these terms. If you see in here, we have r squared in here and we have r cubed in here. What is r cubed? R cubed is actually r squared times r. So it actually consists of r squared as well. So the thing is that we have r squared factor in both of these terms, and we just multiply these factors that are common, and this is the highest common factor between these 2 terms in here. After we found the highest common factor, we just open the bracket, the same thing that we did on the previous example as well. Now we divide each of these terms by this highest common factor. So the first term, which is 2 over 3 pi r cubed divided by this one, would be equal to 2r plus. And what is the second term? It is 1 over 3 pi r squared h divided by this one would be equal to h itself. Now let's solve D. We're gonna rewrite the equation. It is 1 over x squared minus 1 over 2x plus 1. So what I can do, I can write the first term, which is 1 over x squared, as 1 over x squared minus 2 times 1 over x squared plus 1. After I write the equation in here, I see that this is a square trinomial identity. So it is actually looking like this equation. A squared minus 2a plus 1, which is actually equal to a minus 1 squared based off the perfect square trinomial identity feature. So if I actually substitute a with 1 over x, we can get the same equation that we see in here. So this equation, this trinomial identity equation in here is the same equation as in here if I actually substitute a with 1 over x. So what I can do, I can rewrite this equation as 1 over x minus 1 squared. Because if you actually substitute a value in here with 1 over x, you can actually write the equation expression as this. And this would be your factorization. Okay, on this question, we want to factorize quadratic expressions. In order to do so, we first need to know the general form of a quadratic expression, which is ax squared plus bx plus c. Now, if you can find two numbers that their multiplication be equal to a times c, and their summation would be equal to b, you can factorize these quadratic expressions. This method is called the product and sum method. So we're going to start with b as an example. On b, we have x squared plus 6x minus 7. As you guys see in here, our a value in here is 1. Our b value in here is 6. And our c value in here is negative 7. So first I have to find two numbers that their multiplication should be equal to negative 7, and at the same time their summation should be equal to 6. And obviously those two numbers would be 7 and negative 1. Because if you multiply 7 and negative 1, it would be equal to negative 7. And if you add them up, it would be equal to 6. Now, using these two numbers that we got, we're going to split the second term in our quadratic expression. Well, otherwise, the 6x term in here. So we're going to split it into two terms using the two numbers that we already got. So I'm going to rewrite the expression, write it as x squared. Now, instead of 6x, I'm going to write negative 1x plus 7x. At the last, I'm just going to write negative 7 as the last term. So we just basically just splitted the middle term in here into two terms. Now what I can do, I can group the first two terms and the last two terms together. So I'm going to write this as x squared minus x plus 7x minus 7. Now I'm just going to factor out the common factor from each bracket in here. So from the first bracket, as you guys see in here, the common factor is x. So I'm going to factor out x from it. It would be written as x times x minus 1. And for the second bracket, the common factor is 7. So I'm going to factor it out from the expression. So it will be written as 7 times x minus 1. Now, if we look at this expression in here, again, we have a common factor. So the x minus 1 inside the bracket is the common factor. I'm going to do the same thing, and I'm going to factor it out from the expression. So it's going to be x minus 1, 7 plus x. And that will be our final factorization. Now let's solve another example. Let's say that you want to factorize d in here, which is x squared minus 6x plus 9. Now, again, we have to find first two numbers that their multiplication would be equal to 1 times 9, which would be equal to 9, because our a value in here is 1, our b value in here is negative 6, and our c value in here is plus 9. So a times c, which would be equal to 1 times 9, it would be equal to 9. And our summation should be equal to negative 6. So obviously those two numbers would be negative 3 and negative 3 itself. Because if you multiply negative 3 by negative 3, it would be equal to plus 9. And if you add them up, it would be equal to negative 6. Now what I have to do, I have to again split the second term or the middle term in our quadratic expression into two terms using the two numbers that we already got. So I'm gonna write the expression as x squared. Now instead of negative 6x, I'm gonna write it as negative 3x, negative 3x, and the last term was plus 9. Now what I want to do, I want to group two terms in here. I'm gonna group the first two terms, which are x squared minus 3x. Then I'm gonna group the last two terms, which is negative 3x plus 9. Then I'm gonna factor out the common factor from each bracket. So from the first bracket, we have x in here, which would be the common factor. So it's gonna be written as x times x minus 3. And for the second bracket, the common factor would be negative 3. And it can be written as x minus 3. Now, if you look at this expression again, we have a common factor in here, which is x minus 3. And I'm going to factor it out from the expression again. So it's going to be written as x minus 3 times x minus 3. Now, if you just write it in a simpler form, it can be written as x minus 3 squared. Okay, on this question again, we are dealing with more quadratic expressions. We're going to use the same product and sum method that we used on previous question in order to solve them. Let's start with b. We have 2x squared plus 4x plus 2 in here. Our a value in here is 2. Our b value in here is 4. And our c value in here is 2. So we need to find two numbers that their multiplication is equal to a times c, which is 2 times 2, which would be equal to 4. And their summation should be equal to 4, which is the b value in here. So those two numbers would be 2 and 2. Now we're going to split the second term of the quadratic expression into two terms using the two numbers that we got. So we can rewrite the expression as 2x squared. Now instead of 4x, I'm going to write it as 2x plus 2x. And we're going to write the last term, which was 2. Now we're going to group the first two terms together, which would be 2x squared plus 2x. And we're going to group the last two terms together as well. Now what we can do, we can factor out the common factors from each bracket in here. So for the first bracket, the common factor is 2x. So it can be written as x plus 1. And for the second bracket, the common factor is 2. So it can be written as 2 times x plus 1. Now looking at this expression, again, we have a common factor, which is x plus 1 inside the bracket. So we can write it as x plus 1. Now we're just going to write the 2x term in here and plus 2. And that would be our final factorization. Now let's solve another example in here. Let's look at D. We have 5x squared minus 4x minus 1. Again, our A value is 5, our B value is negative 4, and our C value is negative 1. So again, we have to find two numbers that their multiplication would be equal to A times C, which would be 5 times negative 1, which would be equal to negative 5. And their summation should be equal to B, which is negative 4. So those two numbers would be equal to negative 5 and plus 1. Because if you add them up, it would be equal to negative 4. And if you multiply them, it would be equal to negative 5. Now you're going to split the middle term of the quadratic expression into two terms using the two numbers that we got. So we can rewrite the expression as 5x squared. Now instead of negative 4x, I'm going to write it as negative 5x plus x. So the negative 5 comes from n1 and the plus x comes from n2. And we're going to write the c term as well, which was negative 1. Now I'm going to group the first two terms together, 5x squared minus 5x. And I'm also going to group the last two terms together as well, which is x minus 1. Now I'm going to factor out the common factor out of each bracket. So the first common factor from the first bracket is 5x. So it can be written as 5x times x minus 1. And the last one, we have x minus 1 as well inside the bracket. As you see in here, we have a common factor in here, which is x minus 1. So we can actually factor it out from the expression. So it can be written as x minus 1 times 5x plus 1. Now, for the last example, let's look at G. On G, we have negative 2x squared plus x plus 3. Again, we need to find two numbers that their multiplication should be equal to A times C. Our A value in here is negative 2. Our B value in here is 1. And our C value in here is plus 3. So two numbers that their multiplication should be equal to A times C, negative 2 times 3, which will be equal to negative 6. And their summation should be equal to B, which is 1. And those two numbers would be plus 3 and negative 2. Because if you add them up, it would be equal to 1. And if you multiply them, it would be equal to negative 6. 3 times negative 2, it would be equal to negative 6. Now, using those two numbers that we got, we're going to split the second term or the half term into two terms. So we're going to write the expression negative 2x squared. Now, I'm going to use the second number, which is negative 2 in here. Write it as negative 2x. I'm now going to use the first number, which was 3x. Then I'm going to write the last term, which was our c value, which is 3 in here. Now I'm going to split this into two groups. So it can be written as negative 2x squared minus 2x. And the second group would be 3x plus 3. Now I'm going to factor out the common factor from each expression. So from the first one, we can see a negative 2x is the common factor. So it can be written as negative 2x times x plus 1. And for the second one, we have a 3, which is a common factor. So we can factor it out from the expression. So it would be written as 3 times x plus 1. And now, as you guys see in here, we have a x plus 1, which is the common factor again. So we can factor it from the expression, and we can write it as x plus 1 times negative 2x plus 3. Okay, on this question, again, we are dealing with more factorization problems, I want to factorize these expressions in here. Let's start with A. We have x squared plus 9x plus 14. As you guys know, this is a quadratic expression and we have to define the a, b, and c value in here. So our a value in here would be equal to 1, our b value in here would be equal to 9, and our c value would be equal to 14. Now we have to find two numbers that their multiplication would be equal to a times c, which is 1 times 14, which should be equal to 14. And their summation should be equal to the b value, which is 9 in here. And those two numbers would be 7 and 2. After finding those two numbers, we can split the middle term of the quadratic expression into two terms using those two numbers. So we can rewrite the expression as x squared. Now instead of 9x, we're going to write it as 7x plus 2x, and the last term would be equal to 14. Now we're just going to group the first two terms together, x squared plus 7x, and we're going to group the last two terms together as well, which is 2x plus 14. Now we're just going to factor out the common factors from each expression inside the bracket. So for the first bracket in here, the common factor is x. So it can be written as x times x plus 7. And for the second bracket, the common factor is 2. And it can be written as 2 times x plus 7. Now, if we look at this expression again, we have a common factor, which is x plus 7. And we can factor it out from the expression again. So it can be written as x plus 7 times x plus 2. Now, let's say that we want to solve f. On f, we have 3x squared plus x. There you can see we are dealing with two terms in here, which is x and 3x squared. So because of that fact, we can just simply factorize it using the common factor. So the common factor in here is the x value, so we can rewrite it as x times 3x plus 1. And if you want to check your answer, you can just simply multiply the x by each of the terms inside the bracket. So if you just multiply x by 3x would be equal to 3x squared. And if you just multiply x by plus 1 in here, it would be equal to plus x. Now let's say that we want to solve j as the last example. It would be 6x squared plus 7x minus 5. In here again, we have to define our a, b, and c value. Since this is a quadratic expression, our a value would be 6, our b value would be plus 7, and our c value would be negative 5. Now we have to find two numbers that the multiplication should be equal to 6 times negative 5, which would be equal to negative 30, and their summation should be equal to the b value, which is 7. And those two numbers would be 10 and negative 3, because if you add them up, it would be equal to 7, and if you multiply them, it would be equal to negative 30. Now you can actually split this second term of the quadratic expression using these two numbers. So we can rewrite the expression as 6x squared, and we can write it as minus 3x plus 10x minus 5. And now you can just group the first two terms together. So you can be written as 6x squared minus 3x. And you can group the last two terms together as well and write it as 10x minus 5. Now what I'm going to do, I'm going to just factor out the common factor from each bracket. So looking at the first bracket, we can see we have a 3x, which is the common factor. And it can be written as 2x minus 1. And looking at the second bracket in here, we can see that common factor is 5. And it can be written as 2x minus 1. Now looking at the expression again, we see that the 2x minus 1 term in here is the common factor. So we can actually factorize it. and write it as 2x minus 1 times 3x plus 5. Okay, now in this example, we want to rewrite the following expressions without using brackets and simplify them if possible. For this kind of questions, we have to expand the brackets, then we just combine the like terms. In order to do so, let's start with A. So on A, we have 15 minus, inside the bracket, we have 7 minus x. So as I said, we have to expand this bracket in here. How should we expand it? We should multiply the value that is in front of the bracket by the terms inside the bracket. So we have a -1 in here, and we should multiply this -1 by each of the terms inside the bracket. So we multiply it by 7, then we multiply it by -x. So we rewrite the expression. It is 15, but is the multiplication of -1 and 7, it is -7. What is the multiplication of -1 and -x? It is equal to plus x. Now we just combine the answers. So we have two numbers in here, which is 17 and -7, which would be equal to 8. And we have x as well. So we just combine the like terms. Let's solve another one. Let's look at D. We have 2x minus y -x times 1 plus y in here. As I mentioned before, we have to expand each of the brackets. Can we expand this bracket, the first bracket? No, because there is a 1 in front of it. It's not even a -1, so we just write it as like it is. So it is 2x minus y. We just remove the bracket for this one. Can we expand this one? Yeah, because there is a -x in front of it. So what we should do, we should multiply this -x by each of the terms inside the bracket. So we just multiply -x by 1. Then we multiply -x by y as well. Then after the calculations are done, we just combine the like terms. So first, -x times 1, it is equal to -x. -x times y is equal to -x times y. Then we combine the like terms. We have only -x and 2x that can be combined. So it is 2x minus x, which is x. We have a -y in here, and we have a -x times y in here. And that's how it should be written without the brackets. And the last one, let's solve h, and the rest can be solved at your own convenience. So we have 2x times x minus 5 minus x times x minus 2 minus 3x x minus 5. As you see in here, there is a variable x in front of each brackets in here. So we should expand each of these brackets. Then we just combine the like terms again. So we just multiply 2x by each of these terms in here, x and -5. Then again, we do the same thing for -x. We just multiply it by each of these terms. Second term, first term. The first term is x, the second term is -2. We do the same thing, which is -3x multiplied by x, then multiplied by -5. And we're just going to write the answers, then combine the like terms. So 2x times x, let's start with the first, which is 2x squared. 2x times -5, it would be equal to -10x. Then we're going to go to the second bracket. -x times x would be equal to -x squared. -x times -2 would be equal to 2x. Let's go now to the last one, which is -3x times x would be -3x squared. -3x times -5 would be equal to 15x. Now we're just going to combine the like terms. As you see in here, we have the x squared terms in here. So we have to combine these terms. So we have 2 negative 1 and minus 3 in here. So it would be 2 plus minus 1, which would be equal to 1. 1 minus 3 would be equal to negative 2 x squared. Now let's look at the x terms. We have 1 in here, we have 1 in here, and we have 1 in here. So we have minus 10 plus 2, which would be equal to negative 8, and negative 8 plus 15 would be equal to plus 7x, and that would be our solution. Now in this example, again, we want to write the following expressions without the brackets and simplify them where possible. Let's start with A. We have 2x minus 3y plus 8x. As you see in here, there is a negative 1 inside the in front of the bracket, so we need to expand the bracket in here. So what we should do, we should multiply this negative 1 by each of these terms inside the bracket. So there is a 3y and there is a plus 8x. So we have two terms, which is plus 8x and 3y. Now let's write the expressions. It is 2x. What is the multiplication of negative 1 and 3y? It is equal to minus 3y. What is the multiplication of negative 1 and 8x? It would be equal to negative 8x. Then we have to just combine the like terms. We have 2x in here and we have a negative 8x in here. If we just sum them up, it would be equal to negative 6x and negative 3y. Now, let's solve C. We have negative 5x minus 3y. Again, we need to expand this bracket. There is a negative 1 in front of it, so you just need to multiply this negative 1 by each of these terms inside the bracket. So we have two terms. We have 5x, and the second term is negative 3y, not the 3y, so it's the negative 3y. So don't forget the negative sign. Now, you just multiply negative 1 by each of the terms. Negative 1 times 5x would be equal to negative 5x. Negative 1 times negative 3y would be equal to plus 3y, since negative times negative would be equal to positive.